Hello, everyone. Welcome to Backup and Disaster Recovery, Business as Usual, or What Needs to Change Now. This is a brief summary of the talk given by Schlomo Schapiro from Tactic Consulting at DevOpsCon 2025 in Berlin.
Our agenda for this video will cover the basics, data center best practices, 8 key challenges, facing the new reality, and finally, a conclusion. Let's get started. Business continuity is a comprehensive strategy that ensures an organization can keep operating during and after disruptions. It's all about minimizing downtime and maintaining essential business processes, ensuring we stay in business no matter what. When we look at the timeline of backup and recovery, 2 key metrics emerge. Recovery Point Objective, or RPO, which defines how old the recovery data is, and Recovery Time Objective, RTO, which measures how long it takes to recover. It's important to understand that backup is not disaster recovery. Backup focuses on restoring specific items when you still have your infrastructure. Disaster recovery, however, means restoring everything when critical infrastructure is lost. Time is our biggest challenge in the case of disaster recovery. Our guiding principles are clear. Backup enables restore. Comprehensive backup and restore automation enable disaster recovery and business continuity. And ideally, we should use the same backup for both individual restores and full disaster recovery. Let's delve into the backbone of our digital operations, the data center. This is where much of our critical infrastructure resides, and it's essential for business continuity. In a traditional data center architecture, we often see virtual machines running on hypervisors, hardware databases, and various services like firewalls and domain controllers. These are typically connected to central SAN storage and central backup storage, often with tape libraries for long-term archives. An extended data center architecture consolidates important data, enabling central backups and crash-consistent snapshots. Here, backup acts as a platform service, simplifying management and ensuring data integrity across the environment. To reduce our recovery point objective, we follow the backup 1-2-3 strategy. First, take snapshots. Second, replicate those snapshots. And third, perform off-site backups. This multi-layered approach ensures data redundancy and availability. One of the most significant hurdles in data protection is the consistency challenge. Ensuring that all related data across different systems remain synchronized during a backup is crucial to avoid corruption and ensure successful recovery. The consistency challenge arises when applications use multiple servers and services that must match, or when business transactions span across various databases. Solutions include stopping services for snapshots, automating consistency rebuilding after a restore, or, less ideally, ignoring the problem. Next, we face the Restore Time Objective, or RTO, challenge. This is about how quickly we can get back up and running after a disruption, a critical factor for business operations. Consider a catastrophic SAN failure. With 140 terabytes of storage and LTO9 tape, a full restore could take at least 5 days. This raises critical questions about managing external relationships and the feasibility of testing such a lengthy recovery. The restore time is often the biggest unknown in our service level agreements. Our goal is to eliminate this uncertainty by continuously restoring every backup immediately, ensuring a verified recovery system is always ready to switch to, achieving a fixed RTO. The no-restore solution streamlines recovery. Instead of a lengthy restore process, automated restore and verification create a recovery system that is continuously ready. In a disaster, recovery time simply means starting this pre-validated recovery system. Another significant hurdle is the regulatory challenge. Organizations face a growing number of compliance requirements, such as KRITIS, NIS2, DORA, and GDPR, which dictate how data must be managed, protected, and recovered. This brings us to what one may call the 11th commandment of IT. Thou shalt build thy works upon a foundation of order, that in calamity they may be swiftly restored. Essentially, it means we need to proactively take care of the hard stuff now. Various regulations like KRITIS, NIS2, DORA, and GDPR outline main obligations, including resilience of essential services, mandatory risk management, comprehensive ICT resilience frameworks, and data availability. These necessitate robust backup, recovery, and documentation strategies. For a compliance self-check, ensure you have comprehensive backups, detailed documentation, and a business impact analysis. Verify that recovery times meet business needs, especially for site-wide outages, and regularly test your restore and disaster recovery capabilities. Now, let's address the cloud and SaaS challenge. As more businesses move their operations and data to cloud-based services and software-as-a-service platforms, traditional backup and disaster recovery approaches need reevaluation. In modern, decentralized environments, we distribute services and data across many locations and platforms. The critical question then becomes, how do we effectively recover all of this scattered infrastructure and data in a disaster scenario? The decentralized consistency challenge, especially with queues, asks, how do we synchronize backups across disparate systems with varying timestamps? And how do we account for the amount of data and state in transit? The solution lies in application architectures that support reconciliation. The Infrastructure as Code (IAC) challenge introduces new complexities. While IAC automates infrastructure provisioning, it also means our configurations are code. We need to consider how this impacts our backup and disaster recovery strategies, especially regarding consistency. With infrastructure as code, we have multiple backups for different components. The challenge is ensuring that data, code, and configuration fit together seamlessly when it's time to restore, maintaining consistency across all elements. The solution to the IAC challenge is a guiding principle. Everything gets deployed via the same tooling. Application teams take responsibility for deploying code and config, backup tools, and restoring data while ensuring consistency and automating the entire recovery process. The Shattered Restore challenge highlights the difficulty of restoring complex systems. Imagine your carefully constructed data before backup becoming a pile of disparate parts after a restore. With SaaS, a no-restore scenario from the vendor is often the reality, emphasizing the need for your own backup strategy. For example, it is impossible to restore a Google Drive file to the exact same URL or document ID as it had before, breaking all links in case of a true recovery. The Data Possession Challenge distinguishes between ownership and possession. You may own your data, but if it resides with a third-party provider, you might not have direct possession or control over it, which impacts your ability to perform backups or to act in case of a disaster. In the context of SaaS, you might own your data, but the SaaS vendor possesses it. This means your ability to directly back up and control your data is limited, creating a critical gap in traditional disaster recovery approaches. If a SaaS vendor goes out of business or experiences a catastrophic failure, despite your ownership, you might find yourself with no data if you haven't implemented your own independent backup solution. The same holds true if legal or regulatory changes suddenly cut off your access to your own data. Even if you own the data and the SaaS vendor possesses it, without a robust backup strategy on your end, a loss of the SaaS provider could still mean a total loss of your data. This underscores the importance of having your own data copies. Imagine going to court to get your data back. You might be already out of business before you win the case. The Service Level Agreement, or SLA, challenge defines the relationship between you, your data, and the SaaS vendor. It's crucial to understand what your service level agreement actually covers regarding data protection and recovery. Many SaaS vendor SLAs do not guarantee data recovery from accidental or malicious deletion, or even a full tenant deletion. They primarily guarantee technical operations. This example from Google Workspace highlights that you are responsible for your data's protection.
Here are some personal materials that dive deeper into these topics, including the Relax and Recover open source project for automated Linux disaster recovery, a deep dive into the mission impossible of Google Workspace disaster recovery, and implementations of the No Restore solution. Feel free to explore these resources for more in-depth insights. To summarize, in this new era, backup, restore, and disaster recovery are complex. We need fixed RTOs through No Restore solutions, applications owning data consistency, and a clear understanding of regulatory obligations. Automate everything, and beware of SaaS limitations regarding data SLA, possession, and restore capabilities. Thank you for watching. Schlomo is here to help you as a partner, coach, and expert. His focus includes IT strategy, governance, security, compliance automation, and business continuity. Feel free to check out our homepage at tkt.dev/Schlomo for more details and contact infos. Hope to see you soon.